Good afternoon, all of you. Myself, Sweta, Bijali, Maity. Today, I am going to discuss a topic, nodal analysis. Before going to this nodal analysis, you have to know some important definitions. These are node, branch, loop, and mesh. First, what is node? It is the junction in a circuit where two or more network elements are connected together. What is branch? It is that part of the circuit which lies between two junctions in a circuit. Then what is loop? It is a closed path in a circuit in which no element or node is encountered more than once. Then last one is the mesh. What is mesh? It is also a loop that contains no other loop within it. Then nodal analysis. Nodal analysis is more commonly used than mesh or loop analysis for analyzing network. It can be used to determine the unknown voltages of both planar and non-planar circuits. Nodal equations are usually formed by applying Kirchhoff's current law to the nodes with unknown voltages, whereas equations based on Kirchhoff's voltage law. Now discuss what are the procedures in nodal analysis. That means how we can determine unknown node voltages. First step, select a reference node or datum node. After that, reference node, treat it to be at zero or ground potential. Then assign a voltage at each of the other nodes with respect to the reference node. Then at each of these nodes mark currents in the elements as flowing away from the node. From KCL equations, solve the set of simultaneous equations for the unknown voltages. If number of independent node n, then equation will be solved for n minus 1 node. After that, suppose this is a given network, then first you can select datum node or reference node. This red dotted line is the reference node. Then this reference node treat it to be at zero or the ground potential, and it is also known as ground node. It is also known as ground node. After that, after selecting reference node, assign node voltages. For this given network, there are three node voltages, V1, V2, V3. That means there are three unknown nodes. Independent node, how many independent nodes? Three independent nodes. 1, 2, 3. And these three independent nodes having unknown voltages are V1, V2 and V3. After that, how we can apply KCL at each node? This is one example. Suppose the resistance value 500 and there are two voltage at the end, V1 and V2. Then what will be the current? V1 minus V2 upon 500. Then the next example is 500 volt, one connected to the ground potential and another node voltage, suppose V1. Then what is the current? V1 upon 500 ohm. It is actually V1 minus 0 upon 500. That means V1 upon 500. Next, how we can apply KCL at different node. First apply KCL at node 1. Before applying KCL at node 1, you should know what is KCL, what is the statement of KCL. KCL means the algebraic sum of all the currents meeting at a point will be equals to 0. As at node 1, I1 current entering and the another two currents leaving, that means that I1 will be equals to the another two currents. So I1 will be equals to V1 minus V2 upon 500 plus V1 upon 500. Next, how we can apply KCL at node 2. At node 2, here all the currents away from the nodes. That means the summation of all these currents will be equals to 0. So the first, if these three currents are indicated by I1, I2 and I3. So I1 will be equals to V2 minus V1 upon 500 plus I2 will be equals to V2 upon 1K plus V2 minus V3 upon 500. This I3 will be equals to 0. Now, how we can apply KCL at node 3? At node 3, here also I2 entering and another two currents leaving from this node. So the another statement of KCL, the algebraic sum of all the entering currents will be equals to the algebraic sum of the leaving currents. So here I2 will be equals to the another two currents. I2 only entering and another two currents leaving. So I2 will be equals to the summation of these another two currents. Another two currents will be equals to V3 minus V2 upon 500 plus V3 upon 500. Now, if I discuss one example, then it is clear to you how we can apply nodal analysis for a given network. First, select one of the nodes as the reference node. Next, assign the node voltages. Here also there are three nodes, 1, 2 and 3, and node voltages are V1, V2 and V3. As this V1 directly connected to this Vs, so at node 1, V1 is equals to Vs. Then apply KCL at node 2 will be equals to V2 minus V1 by R2 plus V2 upon R4 plus V2 minus V3 upon R3 will be equals to 0. Similarly, at node 3, if we apply KCL, then the equation will be equals to V3 minus V1 upon R1 plus V3 upon R5 plus V3 minus V2 upon R3 will be equals to 0. Now discuss what is supernode, concept of supernode. There are two cases. First case, if you have a voltage source connected between a reference node and a non-reference node, set the voltage at the non-reference node to the value of the voltage source. As here V1 connected to the 10 volt, so V1 will be equals to 10 volt. It is case 1. And then this dotted line, that means V2 and V3, known as super node, by excluding this 5 volt. Because why we exclude this 5 volt? Because we don't know what will be the current for that particular branch. That's why here V2 and V3 known as super node. Now case 2. Case 2, if you have a voltage source connected it between two non-reference nodes, you have applied a KCL and KVL. This is case 2 and it is known as super node. 1, if V1 is connected to the 10 volt source, then it is directly V1 will be equals to 10 volt. And if a voltage source connected in between the two nodes, then these two nodes known as super node. Now, advantages of nodal analysis. What are the advantages of nodal analysis? First, solves directly for node voltages. Current sources are easy. Voltage sources are either very easy or somewhat difficult. Works best for circuit with few nodes. Works for any circuit. So, thank you all of you. I think this lecture will be helpful for you. Thank you again.